Okay, here we are in the lab again, and this is episode 4 of the SD card video series. And if you've watched the other videos, you know that it started out as an SD card project, but now it's a CF card project, and with a USB. So we got the CF cards working, and the IDE interface seems to be working great. So we can move on to the next one. So the next one is we're going to start building our USB interface, our USB to the ISA interface. All right. And so there's a lot of boards out. Well, I can't say a lot of boards. There's some boards out there with USB that goes to an ISA bus, but it's just not quite what I want. I want more power. I want it to be more universal, more modern USB, not just one single function. I want it to have multiple functions. So is what we're going to do is we might have to add a hub, but we're going to have multiple functions. But right now is what we're going to do. We need to emulate, basically is what we need to do is we need to emulate 16C550, or sometimes there's 650s and 450 chips, and that's the RS-232 interface for the ISA. So that chip is just a direct interface to the ISA and and then connects to RS-232. All right, so we're gonna emulate that, and it has registers inside that the BIOS has to read and write through the ISA. So we're going to emulate those registers with some SRAM. All right, so I got some SRAM, and then I got a proto board to adapt the SRAM to the proto card. And so let's take a look at that, and then we'll assemble it, and then we'll come back and talk some more. All right. There's the SRAM chips right there. Put them over to the side for a little bit. Let's unpack this thing here. There's our Proto Advantage card they always send. And we have through hole, but it's surface mount on this end for the board. Put that right there. And we got 2 boards. And they give plenty of headers, don't they? Alright, so that's how it mounts on there. Have to cut this piece and put those on there like this, huh? Looks like, yeah, 2 rows, just like a dip. And then these line it up. So then that goes on there. That's where your chip goes, right on top, just like that. All right. Okay. Okay, so the SRAM chip is a CY62128 SRAM chip. Is a 1 megabit parallel SRAM. It's organized as 128K by 8. So you have 128,000 pretty much 8-bit registers. And we only need like 32, but I mean, this is like the smallest you can get nowadays, and it's only $2.64. So we're not wasting any money, that's for sure. And we might be able to utilize the memory for something else later, but for $2.64, can't go wrong. All right. Okay, so now that we know what kind of chip we have, let's go assemble the proto board and put the chip on the proto board and go from there. Okay, let's take a look here. Put that thing right here. See what we got. Alright. Alright, so let's get a little dab of solder on here so that we can tack it. We want to get a little solder on a pad so that we can tack it on there. And then we want to measure where we want to cut the header. So we want to cut that thing right there. Yeah, I would say right there. All right. Okay. Now, I want to get this thing lined up, centered on here, like that. Except I'm not getting anything on there. Whoa, I got that too hot. Huh. I gotta line the other ones up first. Okay, that's pretty good. And I gotta make sure it's straight. Get some solder on this one here. And line it up straight. Kind of centered. First one's not critical because everything's going to get lined up with the little board on there. That looks pretty good. Now we can just solder the pins. And we'll just spin it around here. Do this side real fast. Then we'll fix that other one. Okay, that's that. Now we gotta fix that pin that I got a little too hot. Sticking out kind of crazy. Actually, I think we can just work with it the way it is. We'll just push it back up on there. Like that. It should be fine. It should be fine. Yeah, it's okay. All right. Now, next thing we want to do, cut the next piece where we need it, which is right here, like that. And then we got to take our little board here. Look at that, they didn't give us like a full amount. What the hell? Look at that. It's okay, but it's just kind of weird that they would do it like that, huh? But that'll make sure it fits on the 0.1 inch on center pitch holes on the proto board. All right, and we'll just solder these pins down here, a couple. Do this side here. All right, that should hold it in place. I'll pop this thing off so we can get to the other pads to solder. It's going to be a little tight. It's kind of tight in there for the soldering iron. Yeah, not too bad though. Just got to be careful not to like rub up against the plastic and make it stink and make a mess. Okay, that's those. Make sure we didn't miss any. That one. Looks a little rough right there. Didn't quite get bonded. These ones didn't. It's hard to tell. I think they're okay. Just the way the light is makes it look like they didn't get bonded good. But we need to make sure they're bonded good. Okay. Yeah, we gotta make sure the solder's on them real good, because we can't go back and fix it later, because it'll be on the board and we won't be able to. So we want to pay real close attention to the pins. Make sure they're soldered on the pads real good. And that looks pretty good. I don't see anything. All right, that should do that side. Now we can flip it over and work on the chip. All right, doesn't say which is pin 1 on here. They don't have any. So we'll just make this side pin 1. All right, yeah, see, they gave us a whole extra one. It's kind of weird. And so we got to peel this package open a little bit here. Just like that. Pull out our SRAM. Alright. Alright, so it's saying let's see. So I guess we're going to put pin 1 over here. It's kind of a weird deal. I'm going to have to look at the data sheet because the mark is over here. Should be over here. This This was a weird device, the way they have the pins. So we'll have to take a look at the data sheet. Do a little bit of solder on one of these pads so we can tack it. Get a little fluxes. Solder doesn't look too good. Alright, see if we can get it. Hopefully my hand isn't blocking it, but this is the angle I have to go at here. Kind of center it best I can. They have a lot of pretty big pads here. It's not too bad for a beginning. Get some flux down on this end here. Like that. Whoop, don't bump it. Alright, so now we just got to move it over just a little bit. Alright. I got to get my tweezers to push it and solder it at the same time. And it's still not quite there yet. This one's a little harder. Alright, I got a little solder short there, but that's okay. We're going to work with that. Okay. Get some more flux. The flux is rolling away from me here. It's not staying on the pads. There it is. Okay, let's get some flux on there. Get some more. It's not sitting flat on me here. Clean this stuff up. There we go. Make sure we got all the pins good. Still need a little more flux right here. I don't know where all the flux is going. Alright, and that should be that. And we'll just spin it around like that. Take a look on this side. More flux, more flux. Alright. Okay. I'd say that soldered pretty good. We'll have to check to make sure. Clean it up with a Q-tip and some denatured alcohol. Okay, that should be that. Okay. Now let's just take a look at it. Make sure everything's soldered good. It's okay. No solder shorts. Everything seems to be soldered good. All right, there we go. All right, there it is. Mm. All right, so then the next step is to take our assembly, our memory SRAM assembly, and stick it on to the proto card. So what we're going to do is we're going to find a place to put this. Probably like over here. It's going to be an 8-bit, so I'd like to get it over here somewhere. We can clean that up enough to get that in there, something like that might work. All right, so and we have right here, we have the 3.3 volt regulator. So what we'll do is we'll interface this with the buffers here, and we're going to change that the card side, the peripheral side of the buffers to 3.3 volts, and that means our SD card, our CF card, I mean, will run on 3.3 volts. So that's going to be another thing we have to do. And another thing we have to do, I want to change this microcontroller out for a little bit better one with USB. This one doesn't have USB, and I believe this board will handle 100 pins, and we should be able to just take this off the board and put the new one on without any problem. And we'll try, maybe we'll get this thing in here like this. I don't know how close we can get it. We might have to move a few things. We're running out of space here pretty fast. But maybe we can just set it in there like that. And we might have to come over here. I don't know. We'll see how it works. That means the wires would have to come from over here all the way over to here. I really want to get them close over here. So we might have to move this stuff right here, clean up this, and just set it right in here like that, huh? That would probably be the best thing, just like that. So that'll be our goal. We'll just try to get that in there like that. And then we'll hook up our interface, change our voltage over, and see if we can read and write to the SRAM. So that's the idea. So let's take a look at the schematic, because so what I really want to do first, I think, is I want to switch the CF card side of the bus of the buffers to 3.3 volts and make sure it all works good before we do anything else. And that way we know we're starting out with a working board. So if it stops working, we know when it stopped working. So I want to know that it works okay with 3.3 volts. There shouldn't be any problem, but we got to prove it. We got to test it. We got to make sure. Okay, so here's the idea for our next step right here. This is what I want to do next. And so our buffers right here, our 245 buffers that interface with the data bus here on the ISA bus, just the lower part, but we have to do both of them because it goes to the chip. But we're only doing 8 bits for the serial, the RS-232 emulation. So, but right here, the BCCB, both of these are going to get chopped out from the VCC, and it's going to get connected to VDD and a 3.3 volt regulator that's already on the board, but I don't have it on the schematic yet. So that's what we're going to do first. We're going to switch it over to the 3.3 volts and make sure our cards can work good and everything. It boots up everything. Then we'll move on. That's what I want to do first. Okay, so I modified the board for 3.3 volts. So here's some photos of how I did it. I cleaned up the wiring for that IRQ a little bit while I was there. And so we'll put it in the machine and test our voltage to make sure that it's good. And then we'll take and put the scope on one of the digital data pins for the data bus and check and see if it was, make sure that the data bus really is at 3 volts, 3.3 volts. So here's our 3.3 volt regulator, and you can see the voltage out wire going to the buffer pins, and then it goes from those pins over to the other buffer, and that supplies 3.3 volts to the peripheral side of the data bus. Okay, so let's put our meter on there and make sure our voltage regulator is putting out 3.3 volts. All right, so we got it turned on and we will check our voltage, and it looks like 3.47 volts, which is A-okay for me. Okay, so now the final test is we're going to take the scope and we're going to attach it to one of the data pins, DO, and make sure that it's 3.3 volts or thereabouts. And then if it is, we can move on. Okay, there's our scope probe on data bit D0. Now we'll turn on the computer and take a look at the scope signals and see what D0 really looks like. And power on. And as you can see, it looks like the signals are pretty much right around 3-point-some volts. Okay, so now the only thing left to prove is that will it boot up? We have to make sure that it boots up with all this stuff that we've been messing with. So that's the final test for this video, is to see if the computer will boot up into the CF cards on 3.3 volts. Okay, there you have it. So we modified the board to run the data bus on the peripheral side to 3.3 volts, and everything measures out good, and it can boot up, and we're at the C prompt, okay, just like normal. So then we can move on to the next step. But there's a few things that we have to consider real fast before we call it done. So if we take a look at our schematic, this is the connector for the CF card, the IDE connector. So you have the data bus here running at 3.3 volts, but you have the reset and all these other read, write, all the other signals are 5 volts. So it works and it's okay, but later in the design, we're going to have to change to where we have some 373 buffers that, or maybe 244 buffers that buffer the rest of the signals at 3.3 volts, so that we're all in compliance with the CF card. So we'll have a 3.3 volt IDE, and we'll put a jumper so you can change it from 3.3 volts to 5 volts, so you can go to a regular hard drive if you want. So we'll put that in the next revision, and then we'll start setting up. We'll ignore that for now, and we'll start setting up for the SRAM. Okay, so there you go. This is the end of part 1. So then part 2, we're going to move forward, and we're going to throw in some buffers for the address for the SRAM, and a couple control signals like read write and stuff like that. And then we should be able to access the SRAM from debug in DOS. So that's what we have planned, and I will see you in the next video.